This is one of the rubber-containing roots from the rubber dandelion that we're trying to turn into a crop for the United States, starting in Ohio. The rubber is contained in these long roots. We've already trimmed some of the top off. Now what we do, we need to know how much rubber is in here, because this is basically a wild species under very rapid, accelerated crop domestication. So one thing we want to have is high-yielding plants that we can interbreed. The fastest way to do this is using near-infrared spectroradiometry, which is this machine here. And this allows us to do high-throughput, rapid rubber quantification in ground root material. So this is our rubber-containing root. So we dry this and grind it up so it's nice and evenly and finely ground. And then this machine will allow us to measure how much rubber it has. So this goes onto this light here. This light shines into the sample and is reflected back. But not all the wavelengths are reflected back because the rubber has absorbed some of them. And we can then determine how much rubber there was. Pour it into that sample holder. Make sure there's no gaps, because if the light shines directly through, that won't work. Position that directly over the lamp. And then take its picture, in effect. We're taking a scan. You can see the green line moves across. Here is the new spectrum. Now, what we will do you want to say what happens next?
Sure. Once I take 3 scans of each sample, those scans will be averaged, and that average scan will be put through the chemometric software, where we will be able to output our rubber value for the sample.
And the really nice thing about this machine is it is also mobile, and we can take it out in the field. The spectrophotometer goes into a backpack, and this goes on a tray in front of the operator. Now this method that we've just been showing you cannot tell the difference between more than one type of rubber. This measures total rubber. Now in the plant though, all rubber begins in the form of microscopic rubber particles in the cytoplasm of cells. However, as the root grows, many of those rubber particles will stick to each other and turn into solid rubber form. But the NIR can't tell the difference. The next method that I'm going to show you is actually how we quantify how much of the rubber is still in the form of latex and can be used to make things like gloves. Now the method we just saw, the NIR, near-infrared spectroradiometry, measures all of the rubber in a root. However, in the plant, when the rubber starts to be made, it's made in individual rubber particles which form at that microscopic level an emulsion like a heavy cream. And I have a bottle of some here that we've made. So in the root, however, this rubber can also be turned into solid rubber while the plant is still alive. The NIR can't tell the difference, so the measurement we get there is both of these together. However, we do have a quantification method that allows us to measure the fraction that is in this form. And this is what Akbar is doing over here. So we take this fresh root, can't do it with dry because all the latex will turn into solid rubber with dry, and he chops it up and then homogenizes it, so you're making a little root milkshake. Then we centrifuge it, which floats the rubber particles like cream from milk. And then we can coagulate that floated rubber into a solid, sort of like a cheese. Then we could just peel it off the top of our little tube and dry it and weigh it. And that tells us what percentage of the rubber was in the form of latex in the root. So now that the centrifugation run has finished, all our latex particles, which are lighter than water, should have floated to the top. As you can see here, we have solids in the bottom, a clear layer in between, and latex rubber floating on the top. Now this rubber we now want to quantify. So we can't take it off like that. So what we actually do is add a drop of acid, acetic acid, and then recentrifuge it, which turns it into a little coagulated pad. We then take that off with forceps and put it on a weigh boat and dry it. And what it looks like then is this. And these can be weighed. And it's in triplicate, so we can get some very good confidence about how much latex rubber did those roots have. We would then take the bagasse, if you could pass me a sample of bagasse, which looks like this. We would regrind this and then use solvents to measure how much rubber was in those roots that was not in the form of latex at point of harvest. Then these two together add up to total rubber. There's a small fraction in there. And that total rubber is analogous to the total rubber we measured with the near infrared, or the NIR. This is an accelerated solvent extractor, unfortunately not currently operational, but this uses different solvents to extract different things. So we can measure the amount of carbohydrate in our roots, we can measure the amount of rubber in our roots gravimetrically, that's weighing, with this piece of equipment. Now some of our gene-edited plants are where we've said try and make less inulin and try and make more rubber. This can quite quickly tell us how. It's much less fast than the near infrared though.